So here what will get cancelled? 2 root gets cancelled. Then from this relation what we got, that H1 plus H2 is equals to capital H. This is sum of the two holes is equals, sum of the depths of the two holes is equals to the total height of the water level. That is what we got in the morning about the ranges. Then after that we got one more thing. That's it, huh? One more thing we have proved by the Torricelli's theorem only. What is that? Yes, time taken. Time taken to empty the tank. Time taken to empty the tank from H to H dash. What is the formula? T is equals to A by A naught into, what is the formula? Under root 2 by G root H minus root H dash. Yes, next, for example, if I say H to 0, completely you are emptying the tank, then T is equals to what will get? A by A naught into root 2 by G into what will get here? H, that's it. Then H2, H by 2, half of the tank. T1 is equals to, what is the formula we got? A by A naught under root 2 by G into root H minus root H by 2. Then H by 2 to 0. T2 is equals to what we got? A by A naught into root 2 by G. How much you will get here? Just root H by 2, that's it. Minus 0 you will get there. Next, the ratio of T1 by T2 we got. How much that is? Root 2 minus 1 by 1. This ratio is important. Remember that properly. T1 by T2 is equals to root 2 minus 1 by 1. That is about the Torricelli's theorem we have discussed. After that, we got the relation between the pressure and then velocity. Wherever the pressure is more, their velocity will be less, and then wherever the velocity is less, at that time pressure will be more. Actually, the lifting process will be happen due to the pressure difference. So from the Bernoulli's principle, if I say P1 plus half rho V1 square is equals to P2 plus half rho V2 square for the same level. Same level, nothing but rho GH is equals to rho GH only. Then this one will create the pressure difference here. P1 minus P2 is equals to half rho into V2 square minus V1 square. So here the difference of the energies, kinetic energies, will create you the pressure difference. Due to that pressure difference, what happens? Nothing but the force will be applied, thrust will be applied for the body. So the main thing is, most of the people are having doubt that how this pressure and then how pressure will be increases, how the velocity will be decreases. That is first of all to just compensate the equation I said that logic. But here the thing is, whenever I take the pressure difference P1 minus P2, at that time what you are getting here? Half rho into V2 square minus V1 square. The final kinetic energy minus initial kinetic energy, delta Ke per unit volume will creates you a pressure difference here, delta P. That delta P is nothing but pressure difference is there, means obviously thrust force will act on the body. So in whichever direction there is a more pressure, at that time force will be acting on that direction only. So here this change in the kinetic energy per volume will creates the pressure difference. Due to that pressure difference only, the upthrust will be acting on the body. Why I have taken P1 is more, at that time P2 will be less, nothing but due to this difference only here. Here P1 we are getting here first, and then here what we are getting? Half rho V2 square we are getting. Initial pressure but final kinetic energy. Final pressure and then minus initial kinetic energy. So only we got here, due to that change in the kinetic energy only, we got the pressure difference. Due to that pressure difference only, there will be a thrust force in the upward direction in case of dynamic lift cases and all. Clear, right? So that is what we have discussed, and then we have discussed so many applications of the Bernoulli's theorem and all, how that aeroplane will get lifted up, and then Magnus effect of the spinning ball, and then even ping pong ball also we have discussed, and after that atomizer spray also we have discussed. So always you have to take that whenever the velocity is changing. The main concept is here, where is the velocity is more, where is the pressure is more, that and all is okay. But the thing is how the mechanism is working means, where there is a energy difference, where there is a velocity difference, automatically energy will be different. Due to that difference in the energy, we will get the difference in pressure. That difference in pressure causes obviously what? Force only, thrust force only. Due to that thrust force only, the bodies will get lifted up. The main thing here you have to remember is, due to the change in the velocity, energy is changing. Change in the energy creates what? There is a pressure difference. Pressure is, if the difference of the pressure is there, nothing but at that time force will be acting on the body, thrust force. Pressure is different, nothing but force is also different only. Net force will not become 0. If it is not become 0, it means the body is not in equilibrium. Not in equilibrium, nothing but it might be lifted up, otherwise it will come in the downward direction also. Anything is possible. The main thing is here, delta P nothing but change in the pressure. Change in the pressure causes what? Change in the force. Due to change in the force, the body cannot be in equilibrium. That might be lifted up, otherwise the water might be coming out of the spray pump. Anything will be happens due to the velocity or difference only. The velocity difference creates the pressure difference. Due to that pressure difference, force will be different, so that the body cannot be in the equilibrium. Clear? For example, the ball is just thrown like this only, horizontally, straightly. At that time what happens? Nothing but the air distribution will be equally on the top and then bottom and then in this side and then in this side. Why? Because that is a uniform. In case of the aeroplane wing, we have seen the aeroplane wing like this. Top surface was there, curved surface, bottom surface was depressed. So due to that depression what happens? Nothing but air at the bottom surface will be less as compared to the top surface. So only on the top surface velocity is more, on the bottom surface velocity is less. This velocity difference creates you the pressure difference. Where that is more, where that is less and all, you just forget about that. The velocity difference is creating the pressure difference. That pressure difference causes the thrust force. So net force is not equals to 0. If net force is not equals to 0 means the body is not in equilibrium. That is about all the lift cases and all. The main thing is here, velocity is changing. How the velocity changes and all, you have to mainly identify practically, that is whenever the ball is exactly moving like this, at that time air is uniformly distributed in all the directions whenever it is going straightly. At that time what happens? Nothing but all the directions velocity is same. Velocity is same, nothing but pressure difference how much? Velocity same means pressure difference how much? 0. If pressure difference 0 means force difference also 0. Net force is equals to 0, so only it is not getting lifted up, otherwise it is not falling down. It is going exactly straightly. For example, whenever I am spinning it, it is dragging the air along its surface. It is dragging the air like this. At that time what happens? Nothing but on the top surface there will be more air, so that more velocity, and the bottom surface less air. Why? Because whenever the air is going like this, at that time some of the air layers will fall down. Everything will not be rotated around the ball, right? From the top surface, for example, the ball is spinning like this. You just assume that it is spinning like this. Now what I am doing? Nothing but I am just dragging the air along the surface of the ball. So on the top surface, okay, air will be dragged, okay, it will be dragged until here. It has to turn round and then it has to go back actually. So while going back, less layers of air will go in the downside direction, so that only velocity will be less at the bottom and then velocity will be more at the top. So only due to that velocity difference there will be a pressure difference and then upward thrust will be there. That is how all the mechanism will work based on the Bernoulli's theorem. Then next one is about this one only, this Torricelli's theorem only. We will solve the problem as two liquids. Actually everything we have discussed about only one liquid only. Now I will just take the interface of two liquids here. Two immiscible liquids I have taken, so that you have to get the velocity of efflux relation. Here one hole is there, here another hole is there. So at that time here the density of the liquid is 2 rho, here the density of the liquid is rho. At that time how the velocity of efflux will be there? It will be different obviously. Why? Because the heights of the liquids are different, here heights of the holes are different. So that what is the velocity ratio you will get? That is what we will find in the next problem. Clear? Write a problem. And before that we will solve normal basic problem 1. A horizontal pipeline carries water in a streamline flow. A horizontal pipeline carries water in a streamline flow at a point along the pipe where the cross sectional area is where the cross sectional area is 10 centimeter square, 10 centimeter square. The velocity of water is 1 meter per second. Velocity of water is 1 meter per second, and the pressure is 2000 Pascal. And the pressure is 2000 Pascal. Then what is the pressure? What is the pressure at another section? What is the pressure at another section where the cross sectional area is 5 centimeter square, where cross sectional area is 5 centimeter square. Already we have solved this kind of problem yesterday only. What is the velocity? Yes, very good Ramesh, very good. Solve that. Read the question first. 2 is the velocity. Very good question. Velocity is 2. Two is the velocity. Pressure? How much? 3500. No, 500 Pascal is the answer. 500 Pascal is the correct answer. Yes, you got it. 500 Pascal is the correct answer, and then velocity is 2 meter per second. See that? A horizontal pipeline carries the water in a streamline flow at a point along the pipe where the cross-sectional area is 10 centimeter square, and then the velocity of water is 1 meter per second and the pressure is 2000 Pascal. They have given that the cross-sectional area is different. First one is 10, next one is 5. Yes. Like this, a pipe is there. Here, whenever the area is 10 centimeter square, at that time velocity is how much they said? 1 meter per second. And the pressure is how much here? 2000 Pascal. Now, given the second area, A2 is equals to how much? 5 centimeter square. You have to find out the V2 as well as pressure P2 also. That is what the question they have given. I said whenever you have seen the two areas, asking the velocity, immediately what function, what equation? Equation of continuity, that is A1 V1 is equals to A2 V2. From that V2 is equals to A1 by A2 into V1. A1 is how much here? 10 by A2 is 5 into V1 is 1. Then that is 2 meter per second. That is the velocity. I got the velocities and then I have to find out the pressure at the same level only. Horizontal pipe they have given. So that what you have to apply? Bernoulli's theorem you have to apply. Pressure you know, and then velocities you know. Heights if you know, or if you don't know also, whichever is same nothing but potential difference will be how much? 0. Now what I can apply here? P plus half rho V1 square is equals to P2 plus half rho V2 square. P1 is how much we got? 2000 Pascal, and then half into density of water is how much? 1000. Water is flowing here 1000, and then V1 is 1 here. That is equals to P2 you have to find out half into, again density is 1000 here, V2 is how much? V2 square is 4. Then this will be 500, 2500, then this will be 2000. 2500 minus 2000 gives you 500 Amma Rajeshwari. ಓಕೆನಾ. ರಾಣೆಬೆನ್ನೂರೇನಾ ನಿಮ್ಮದು? ಅಲ್ಲಿ 3500 ಆಗುತ್ತೇನಾ? ಇಲ್ಲಲ್ಲ. ಸೊ 500 Pascal is the correct answer. Next, one more variety in the Torricelli's theorem. A cylindrical vessel contains a cylindrical vessel contains a liquid of density rho up to a height h. A cylindrical vessel contains a liquid of density rho up to a height h. Up to a height h. Then the liquid is closed by a piston. The liquid is closed by a piston of mass m and area A. Of mass m and area A. Full stop. There is a small hole at the bottom of the vessel. There is a small hole at the bottom of the vessel. Find the speed v. Find the speed v with which liquid comes out of the hole. Find out that. In terms of equation only you get the answer. You can consider the points anywhere and then you can apply the Bernoulli's theorem. That's it. The equation you will get here as rho gh plus mg by a is equals to p naught plus half rho v square. Shall I explain? You will get the equation as rho gh plus mg by a is equals to p naught plus half rho v square. Correct? Anybody got that? Atmospheric pressure 0 ಆಗುತ್ತೆ. Yes, look at the board. Here you can consider the points anywhere. You can consider the points. Second one, this one is one of the point, obviously the orifice is one of the point. Let me take point 2. Point white you might consider anywhere. That might be top of the liquid, otherwise just inside of the liquid also. Anywhere you can apply. Let me take, I will take at this point only. Point 1 and then point 2 are there. You have to apply the Bernoulli's theorem at point 1 and then 2. So at 1 and 2 you have to apply the Bernoulli's theorem means at 1, is there any air atmospheric pressure? Nothing, that is closed completely. Closed by a piston of mass m and then area is how much? A. We are not applying any force there. Actually what happening, nothing but whenever the water is coming out, obviously this piston will be coming down. That's it. Nothing but how much pressure you are applying, nothing but here force divided by area. How much force piston is applying here? mg is the force divided by at what area? A is the area. So at this point the pressure is, let me take P1 plus half rho V1 square plus rho g into H1 is equals to P2 plus half rho V2 square plus rho g into H2. That is the Bernoulli's theorem we have to apply. Now at point 1, what is the pressure? Nothing but pressure is, atmospheric pressure is nothing, 0. Why? Because the vessel is closed. Whenever it is closed, atmospheric pressure is 0. But which pressure is there? Nothing but piston pressure is there. Piston is having some weight nothing but force. So that force by area gives you how much? Pressure. So that is the pressure here, mg by A. Mainly you have to get that idea. That's it. That is the difference in the other problems and in this problem. That's it. Now here, whenever it is moving under gravity only, so that V1 becomes how much here? 0. Then rho g into, this point is there at what height? H height. So only rho g h, that is equals to P2. The pressure at the second point is how much? Open to the atmosphere, that is, so that what I can get here? P0 plus half rho into the velocity I have to find out. Then rho g h2 is equals to how much? 0. Why? Because on the ground we are considering this one, bottom of the tank. Then this will be the equation, that's it. Whenever numericals given, you have to substitute in this only. The main thing is, whenever the vessel is closed, at that time how to apply the Torricelli's theorem. That is the main motto of this problem. Then next problem. Pump draws water from a reservoir. A pump draws water from a reservoir and sends it through a pump draws water from a reservoir and sends it through a horizontal pipe with speed v. Then find the relation between power of the pump and velocity of the liquid. Then find the relation between power of the pump and velocity of the liquid. You have to find out the relation between power and velocity. Try that. First of all, read question. In question what they have given, what you have to use. Water bottle. Just tell me P is directly proportional to V power how much, that's it. Actually power is equals to, what is the formula for us? Force into velocity, otherwise work done by time, otherwise energy by time. Yes sir, it is the water is flowing with velocity V, they said. So that you have to use the velocity there, means you have to use the kinetic energy obviously. So power is equals to kinetic energy by time I can take. But did they give anything about the time here? Nothing given. But they have said that water, it is just taking the water and then sending. Nothing but density is given, rho is given, velocity is given. Only these two components I have. And then pipe they have given nothing but area will be there obviously. So how to do that? Time is not there. Instead of time, what you can get? Rho V is there nothing but what is the kinetic energy formula? Half rho V square. What is that? Kinetic energy per volume. But not only kinetic energy. Kinetic energy means half into delta M into V square we got. But we got that kinetic energy per volume. But is there any volume here? No volume. So that what I will do? Nothing but volume divided by volume I will do. Clear? Now this kinetic energy per volume is what here? Half rho into V square. So that half rho into V square. Then what about this volume and time? What about this one? Volume and then time. Yes, constant. Then whenever it is constant, then what we can write it as? A into V. Who said that that is constant? Somebody said that constant. dV by dt. dV by dt. Here volume by time. Volume by time nothing but equation of continuity states what? The amount of water flowing per second is equals to always constant. So that what I can say here, area into velocity is constant only, right? Here we got already yesterday we have discussed so many times, that is dm by dt is equals to constant. It is the equation of continuity. Then mass is equals to what? Density into volume. So that only density into dv by dt is equals to constant. However, density is constant only. Then this dv by dt is equals to what we got? A into v, area into velocity. From that only we got a1 v1 is equals to a2 v2. So here volume by time nothing but indirectly I can write it as what? Half rho velocity square into volume by time nothing but area into velocity. Then half rho into area into velocity cube. See that here rho is the density. It is just sending the water only from initial point to final point. There is no change in that, that is constant. Area, uniform cross section and different cross sections. Uniform cross section, pipe is not changing the area, so that area is also constant. So clearly what I can write here, power is directly proportional to velocity cube. In the work power energy also you will get the same relation. Do you remember or not? We got heart pumping that problems and all there, power problems and all. Power of the motor which is pumping the water for V meters per second, same problem there also we got same thing only. Power is directly proportional to V cube only. Clear? In the work power energy chapter also. The same thing here also. Generally they have said that the pipe is taking water from the reservoir and then sending to something other place, and then with what velocity? Nothing but with V velocity. That is what they are giving. So with V velocity nothing but they are saying that water means density is there, pipe means area is there, V means velocity is there. That's it. There is no time, nothing. So you have to take the power relation is what? Work done by time, otherwise kinetic energy by time. Why? Because velocity is there here. Now Ke by T is equals to volume. Here I don't know the kinetic energy. I know the kinetic energy per volume. What is that? Half rho V square. For that I am multiplying with volume and then dividing with volume. Kinetic energy per volume is half rho V square, and then volume by time nothing but again that is a equation of continuity only, that will be always constant. What is that constant here? A into V only. So that AV I have written, then P is directly proportional to how much here? V cube. That is not pressure, that is power. Clear? Let's copy that. Next, write a problem. You can work on this. A liquid of density 1200 kg per meter cube. A liquid of density 1200 kg per meter cube flowing steadily in a tube of varying cross section, full stop. The cross section at point A is 1 centimeter square, and that at point B is 20 millimeter square. The points A and B are in the same horizontal plane. The speed of liquid at A is 10 centimeter per second. Then calculate the difference in pressure. At A and B. Difference in pressure at A and B. This problem you can solve. Later you can do that. Next problem you write. A tank is filled with two immiscible liquids. A tank is filled with two immiscible liquids of densities 2 rho and rho, and each of height h full stop. Two holes are made to the side wall. At h by 2 and 3h by 2. At h by 2 and 3h by 2. At h by 2 and 3h by 2. From the upper surface of the liquid, then find the ratio of velocity of a flux. Then find the ratio of velocities of a flux through the holes. Find the answer. If anybody get that, I'll give you a chocolate. Liquids of different densities and same height. What is the V1 you got at least? Anybody got V1 at least? Root GH. Very good. Correct. V2 mate? No. V2 नहीं, V1 root GH आएगा. V2 फाइंड आउट करो. मन भाई रूट थ्री जी एच ಇಲ್ಲ V2 ಬೇರೆ V1 is root GH. V1 by V2 ना V2 is नहीं एरियास नहीं दिया ना root 3GH. No, V2 is not root 3GH. Two are immiscible liquids, don't mix them. How many of you got V1 is under root GH? Very good, very good, very good. See that I will give you one hint that always you have to apply the Bernoulli's principle within single liquid only. You understand or not? Nothing but you are applying the Bernoulli's principle for this, nothing but only within this liquid. For this whole, nothing but only within this liquid. You understand, right? You should not take the Bernoulli's principle between the topmost point and then this point. Why? Because here this density is different, this density is different here. You understand, right? Till now whatever we have discussed about the single liquid only, but this is a double liquid here. No, root 2GH barabeku, V2. Root 2GH you got. Okay. See that I'll explain. First one root GH you got very good about that. Now second one you have to find. For that first of all we'll see the first one. Let us consider different points first of all. Let me take here point A and then this hole is there at point B. Next this is the point C. Let me take this hole is there at point D. The main thing why I have considered the point C nothing but here Bernoulli's principle you can apply only for the single liquid. Left side is equals to right side for the single liquid only. Whenever we have seen the Bernoulli's principle pipe, in that only water was flowing, not different liquids. So here also you have to take at the single liquid only. So for that first of all let me take at point A and B I have to apply the Bernoulli's principle here. Two are immiscible liquid, they are not mixing together. First one is separate and then second one is separate. You have to find out the V1, V2 velocities. For that, first of all, let me apply the Bernoulli's principle at point A and then B. A and B I will apply. So, the point A and B are there in the liquid of which one? Rho is the liquid density here. Now, point A pressure is how much? Which pressure is there? Atmospheric pressure P0 is there on the top, open end. Then P0 plus kinetic energy is how much here? Half rho. V square becomes how much? 0. Why? Because the liquid is falling freely here. Then next potential energy is how much? Rho G into, this is the ground. From ground point A is there at what height? 2h height. Point A is there at 2h height. So that rho G into 2h. Either you can consider this one as a potential 0 level, otherwise this interface also 0 level you can consider. Anywhere you can consider. That one also I will prove if you want means. So here rho G into 2h that is equals to. Now point B, we are discussing about the point B. Again at point B also which pressure is there? Atmospheric pressure P0 is there plus kinetic energy is how much here? Half rho V1 square plus potential energy is how much? Rho G into, from the ground at what height? From the ground h by 2 and then h by 2. 3h by 2 is the correct answer there. So that 3h by 2. Then here P0 gets cancelled, rho gets cancelled everywhere. Then what is remaining here? 2gh minus 3gh by 2 is equals to half rho V1 square. Correct? Then 2, 3 nothing but this will be how much? 4 minus 3 nothing but just gh by 2 is equals to half rho V1 square. Then half of gets cancelled. Then rho also got cancelled, right? Rho is not there here by the way. Then V1 is equals to how much you will get? Under root GH. That is about whenever we have considered the ground here. Otherwise, if we consider this is a 0 potential energy level. In method 2, I can get again. In method 2, I can get it as, I will take it as 0 potential energy level. Why? Because this liquid is not depending on this one. Completely this one is separate and then this one is separate. But 2 rho is depending on rho. Why? Because on 2 rho, the weight of the rho is acting here. You are understanding or not? For example, you are standing, one person is standing on the other person. For whom weight will be there? Down person only, right? The same thing only here also. This liquid is bearing the weight of this one. Nothing but the pressure will be different for that case. For this one nothing will happen. If it is standing on the ground also, the person is standing on the ground, otherwise shoulders of that person also, the same thing only, nothing is happening to him. In the same way only, here whenever I consider this as a zero potential energy level, at that time again I apply the Bernoulli's principle at A and B. For that at A, what will get here? Pressure is how much? P naught plus kinetic energy is how much? 0. Potential energy is how much? If I take this as a 0 level, from here how much height is there? H height. So that only what will get here? Rho GH is equals to, this one is how much? Again P naught plus half rho V square, V1 square, plus from this 0 energy level, this will be there at what height? H by 2 height, right? This hole is there exactly, this is a 0 level and I have taken. Now this is there at a height H by 2. So that only rho G into H by 2. Now P naught gets cancelled, rho gets cancelled everywhere. GH minus GH by 2, how much you will get? GH by 2, that is equals to half V1 square, half of gets cancelled. Again V1 is equals to how much? Root GH only. I said so only that you will have full freedom for selecting the 0 energy level. In the work power energy only I said that so many times. Wherever you want you can consider the 0 potential energy level. So V1 is equals to how much you got? Root GH. Anywhere you can consider either ground, otherwise just interface also you can consider. That is about the velocity V1. Next velocity V2 is important here. For the velocity V2, you should not consider the point A and then D. Why? Because point A is there in the different liquid, point D is there in the different liquid. But whenever we solve the Bernoulli's principle theorem, at that time we have taken the pipe with the different cross sections. But in that pipe only water was flowing, otherwise only one fluid was flowing. So here also you have to take only single fluid. You cannot apply the Bernoulli's principle for the two different fluids. So only here I have to take either this one 2 rho, exactly 2 rho I have to take. In that I have to consider the 2 points. At that 2 points you have to apply the Bernoulli's theorem. So for C and D, for C and D Bernoulli's theorem I will apply. I will take the ground level as a 0 energy level. Then at C what is the pressure? Tell me now. At C what is the pressure? Tell me. Just below the interface. At this point what is the pressure? Rho GH. This point is having the weight of this liquid only, right? Which liquid? That is rho liquid. Into G into what is the height of the water column here? H is the water column. So only the pressure is equals to how much? Nothing but rho G into H. By the way, P naught also you will get. On the top P naught is there already. P naught plus rho GH. That is equals to the pressure of C. You understand clearly? See, PC is equals to, the pressure at C is equals to, you will get the atmospheric pressure. Why? Because the vessel is open, and due to the height of the water column you will get some pressure. Rho G into what is the height of the water column here? H. And then on that which liquid is there? Nothing but rho liquid is there. So only you have to take that as a rho GH. Most of the people might be done mistake in this only. They might be taken that as 2 rho GH. So here P naught plus rho GH, that is the pressure energy. Next kinetic energy is how much? 0. However, potential energy of point C is how much? From ground what is the height? H is the height. So in which liquid it is there? 2 rho liquid. So that 2 rho into G into H. General our potential energy formula is what? Rho GH only. But here how much rho is there? Nothing but 2 rho into G into H. Don't confuse between this and then this. Here this is entirely the pressure at point C only. The point C is bearing this much of water liquid weight here above that. So only the pressure is atmospheric pressure plus height of the water column with whatever the density we are having. That's it. That is not, I am not saying that is just belongs to the point C, means it is belongs to 2 rho only. The point is belongs to 2 rho only, but above that which density is there? Nothing but only rho density is there. That will gives you the pressure here. This is entirely pressure only. Just remember that. And this one is which one? Potential energy. Potential energy per volume. So potential energy is nothing but what is the formula for us? Rho G into H. But instead of which liquid point C is there? 2 rho. So only 2 rho into G into, at what height it is there? At H height only it is there. So only 2 rho GH. Then next one is point D. Point D is also open to the atmosphere, P naught. Then kinetic energy is how much here? Half rho into V2 square. Potential energy is how much? Potential energy. Point C is there in the point D is there in which liquid? 2 rho liquid. So that 2 rho G into this point D is there at what height? H by 2 height, right? So that H by 2. Yes, very good, very good. Half 2 rho. This one is half 2 rho into why? Because the point D is there in which liquid? Nothing but 2 rho liquid only. Now here everything gets cancelled. Then what will get here? P naught also gets cancelled. How much is there here? 3 rho GH minus rho GH is equals to rho V2 square. Rho gets cancelled. Then V2 is equals to how much you will get? Under root 2 GH. The ratio of the velocity V1 by V2 is equals to 1 by root 2. That's the correct answer. Everybody understood, right? So you can consider the zero level anywhere and then you can get the answer. And also the main thing is Bernoulli's theorem will be applied only for the single liquid. And then one more confusion point is here, point C. For point C, what is the pressure? By the Pascal law only we know the pressure, P naught plus height of the water column only. Here height of which column is there? Nothing but rho column is there on that. So only rho G into G into H. Next, this is the potential energy. And after that at point D again you are applying the Bernoulli's theorem here. So instead of taking rho and then 2 rho, if you take that as rho 1 rho 2, then your answer will be correct, I guess so. You will not confuse there. If you take this as rho 1 and then this is rho 2, in the final answer if you substitute that values, then you will get the correct answers. Clear? Yes. Copy both the methods for A, B. Write a problem. A cylindrical tank 1 meter in radius, a cylindrical tank 1 meter in radius rest on a platform 5 meters height. Initially the tank is filled with water to a height of 5 meters. A small hole of area 10 power minus 4 meter square is open at the bottom of the tank. Then in that first question, find the speed with which water flows out from the orifice. Next question, initial speed with which water strikes the ground. First question ಮತ್ತೆ ರಿಪೀಟ್ ಮಾಡಬೇಕಾ? ಆನ್ಸರ್ ಬಂತಾ? ಎಷ್ಟು? ವೆರಿ ಗುಡ್, ಕರೆಕ್ಟ್. Shall I repeat, Yuvaraja? You got the question? Second one, initial speed with which the water strikes the ground. You can get the answer for that easy only. and draw the diagram by the way, and we will start the viscosity. Platform is there at 5 meters height, and then tank water filled at 5 meters height only again. Nothing but whenever the water is coming out of the orifice, speed of efflux you have to find out, and then striking speed also you have to find out. Again you have to apply the Bernoulli's theorem only for that. Speed of efflux is how much for us? What is the formula? Under root 2g into depth of the hole only. So how much answer you will get? 10 meter per second. For the second question you have to apply Bernoulli's principle between this one, between this point and then this point. Then you can get the answer there. Clear? Otherwise you can apply even at the top point and then bottom point also. Everything is same. The next one is viscosity. What do you mean by viscous force? What do you mean by viscous force? You know already viscous force. What is that? Viscous force means? Yes, very good. The viscous force nothing but that is a frictional force. Where the frictional force will be there nothing but between the layers of the fluid, whatever the fluid we have taken. Even air is also fluid only. Between that layers also there will be a frictional force. That friction is known as what? Viscous force. Viscous force means normal in mechanics, whenever two bodies are sliding on each other, at that time what will be produced there? Friction will be produced. If water is flowing nothing but the layers are sliding on each other, even between them also there will be a friction. That friction is known as what? Viscous force, that's it. So, and also one more important thing is, that is important for the theory questions. Whenever we have taken the river, at that whenever you consider the river, you might be seen in the Discovery channels also. In the river what happens nothing but the water which is near to the ground, that will be still, that will not flow. Water on the top surfaces will be flowing. You understand that? You are able to assume that. Only the water layers which are at the top layers, they will have more velocity, and the bottom layers which are near to the ground will have the still water, that will be. Nothing but the velocity is almost zero only. So only this whatever the fishes are there, and then whatever the aqua life will be there, that will be most of the time that will be at the bottom of the river only. In pond, in lake, nothing but they will be there everywhere, but inside of the river means they will not be there on the top, they will be there on the bottom layers. Why? Because top layers will be flowing with a high velocity, bottom layers will not be flowing, so only they can live there happily. Clear? So always you have to remember that. For example, if I consider this as a river, in that river the water will be flowing, but the top surfaces will have more velocity. Whenever I am coming like this down and then down and then down, then what happens? Nothing but velocity will be decreasing. You are able to assume that. So here the big arrow indicates that both are having more velocity, so only they are moving fast. Whenever once the water is starting its journey at this point exactly, the which layer will move fast? Nothing but top layer will move fast. So only its displacement is more, and the bottom layer will have little bit less velocity, and then less. Like that here almost zero velocity will be there. Whichever the layer is there in the connection with the ground, that will have the zero velocity almost. And also whenever you consider the pipe also, in the pipe how the structure will be there? Nothing but, for example, if I take this as a pipe, in that pipe actually middle layer will have more velocity. What is the reason? Middle layer will have more velocity. What is the reason? Actual diagram will be there like this. See here the layers are near to the ground, here the layers are near to the pipe, that's it. However, the connection is same only, right? So here they will be sliding like this, like this. Nothing but whichever is there, whenever you see, whenever you are planting, you are just watering the plants also, at that time you might be observed that whenever you are just holding the pipe like that, at that time what happens? Nothing but the water will come from the middle exactly. From the down whatever is coming, it will just fall near only. Whichever is the middle layer is there, that will go far away, which is near to the pipe at the bottom end. Above end you cannot observe that much easily, but bottom end you can observe. Water will be, drops will be falling down. What is the reason? Nothing but they are not having any velocity there. Whichever are having the middle layers will have more velocity. Why? Because Here nobody is attracting them in middle, they are moving freely. Only viscous force between the layers is there. But here what happening, nothing but this water is different and then this pipe is different. Whichever the water layers which are near to the pipe are having the less velocity, which are far away from the pipe are having the more velocity. In the same way, the water layers which are having far away from the ground will have the more velocity and then less velocity at the near to the ground. Clear? This one river one you can understand very easily. Clear? So that is about the viscosity. Before viscosity, how the water flow will be there means this is how it will be there. And also now in this, between any two layers I will consider, this is the first layer and then this is the second layer. Between them obviously one layer is sliding on the other layer. In between them what will be produced there? Friction. That friction is known as the viscous force here. For example, if I draw the diagram in 3 dimension, let me take, this is the first layer of the water, top layer, first layer, this is the first layer. Then next one is, this is the second layer of the water. This is the second layer and then this is the first layer. Now this is having the velocity v means this will have more velocity or less velocity na? More velocity, right? We are moving above that, above the ground nothing but it will have more velocity. Let me take the velocity is v plus delta v. V is this velocity and then we are having more velocity, how much more, nothing but that is a delta v more. And now from the ground this layer is there at y distance means this will be at what distance, nothing but y plus delta y. Clear? So Akshita, control Akshita, control. Y plus delta y and then this is at what height, nothing but exactly at a y distance. The distance between, the separation between the layers is how much here? Delta y. The difference of velocity is how much here? Delta v is the difference of the velocities. Now the thing is, what viscous force will state nothing but viscous force will be always directly proportional to the area of the fluid layers. If more area is there, obviously more friction. For example, if I consider, for example, if I am just moving this one pen on the other pen, then what happens, nothing but friction will be less. If I consider two hands together having more area nothing but more surface in contact. So there is a more contact at that time, more friction obviously. You are understanding that? So that viscous force is directly proportional to area. And also the viscous force is directly proportional to the velocity gradient. What is the velocity gradient? Delta v by delta x. So that velocity gradient is delta v by delta x. How it will happen, we will see. Delta x, otherwise in this case we have taken that as delta y. For example, there is more separation. At that time what happens, nothing but friction will be less or more. Whenever more separation is there, nothing but at that time friction will be less. Whenever I am taking near to each other, whenever I am pressing them even closer, at that time what happens, friction will be more. So only whenever the separation increases, then friction is decreasing here. Whenever you are just applying the sudden brake for a high speed car, at that time what happens to the tire? It will get damaged, right? What is the reason? You are going with a high speed and then suddenly braked. Then what happens, nothing but due to more friction, their kinetic energy is there obviously. That kinetic energy will convert it into the heat energy due to the friction. So that what happens, nothing but the car will get damaged more, the tire will get damaged more. For example, you are going slowly and then you are applying the brake, nothing will happen. Why? Because if the velocity is increasing means, then also friction will increase. So only here the difference of the velocity is increasing, then friction is increasing. Friction is directly proportional to the velocity, friction is inversely proportional to the separation. You are understanding that? So that the viscous force is directly proportional to the area and then directly proportional to the velocity gradient. Then together what I can write here? Together what I can write there? Viscous force is directly proportional to what I can write? A into delta V by delta Y. Clear? Now this proportionality can be removed by a constant known as the coefficient of viscosity. You already studied the formula of the coefficient of viscosity in the units and dimensions. What is the coefficient of viscosity formula you have studied? Pressure divided by velocity gradient. You have studied this formula only in case of units and dimensions. The same thing is happening here. So here Fv is equals to neta into A into delta V by delta V. Then neta is equals to what will get here? FV divided by area, that whole divided by what you are getting here? Velocity gradient. Force by area nothing but what? Pressure. And then velocity by distance nothing but that is a velocity gradient. That is a coefficient of viscosity here. So that clearly neta is equals to, I can write it as Fv by A into delta V by delta Y. That is the coefficient of viscosity. Clear, right? The coefficient of viscosity, as like Coulomb's law is directly proportional to the what is that? Product of the charges, inversely proportional to the distances. In the same way, here also you will get the force is, the viscous force is directly proportional to the area. For example, if I am taking a very smaller area, for example, I have taken any two objects, for example, two erasers I have taken and then I am rubbing in between them. It will have less friction. Whenever you are taking two books together and then you are rubbing, at that time what happens? More friction, more area of contact, there is a more friction. More velocity, I am rubbing very fast, at that time more friction. I am rubbing very slowly, at that time less friction. So more velocity means there is more friction. Velocity difference is more nothing but there is a more friction. Now I am just lifting little bit up and then I am rubbing. What happens? Friction will be less. Separation is increasing, friction is decreasing. So only separation is increasing here, friction is decreasing. Yeah, frictional force is inversely proportional to the separation, directly proportional to the velocity and also directly proportional to the area. Now together I have written as Fv is directly proportional to A into delta V by delta Y, and then proportionality removed by a constant known as the coefficient of viscosity. Then neta is equals to, this is what the formula we got. Force by area into velocity gradient. That is what the coefficient of viscosity. So here viscous force nothing but what? The opposing force which opposes what? Opposes the relative motion of the fluid layers. Okay, always friction also I said, it will not oppose the motion, it will oppose which motion? Relative motion. Clear? Write that, viscous force. Viscous force is opposing force. Opposing force opposes the relative motion of fluid layers. Relative motion of fluid layers. Copy everything. This derivation and then this diagram you copy. All the diagrams you copy, I will tell the notes. Okay.